Alright, guys. Hi, and welcome to my channel. Starstruck Rambler here, and here to give you some information on my last video. Um, Now the first one, okay, this is just gonna be a quickie video. Now, the first part is with that large planet um, that has this mass of 17 Earths. Now it's called Kepler 10c, and like I said before, it has a mass of about 17 Earths, and it orbits a star, a G, a G-type star, which are now stars of the G class are stars that are similar to the Sun. Now the Sun is also a G-type star. Now I will talk more about stars in another video, or one of the days after I'm done with the house setting is where I start a extra series with stars. Yay! Finally, um, can't wait for that part. Oh, I'm so giddy for that part, for that series. Oh my gosh, I'm so into astronomy. Now anyway, G-type stars, which the Sun is included, are basically stars which are similar, including the Sun, well, to the Sun. Um, yeah, anyway, um, Kepler 10c is quite unusual and just doesn't fit into the models that we have of planet formation. So, further research needs to be done on that, especially on my part. Um, During the house setting period, I will look more into it, see if I can find more about this. But currently, just doesn't fit into the models that we have of planet formation. Now, this other star, planet, that we found recently, just a few days ago or so, um, that other one that I talked about, that's where we're not sure if it's a brown dwarf or planet, is yeah, it's about 22 22,000 light years away. Um, yeah, 22,000 light years away, and it's called. Oh my gosh, is this a long name? Um, Ogle 2016 BLG 1190. Oh my gosh, the names that they come up with these for these planets or stars and other objects. Now, it has a mass of about 13 Jupiters, uh, which is quite large. Um, as you know, Jupiter has a mass of about 318 Earths. So which is quite hefty even for our solar system. Now, Jupiter alone already has a mass of 2.5 times the mass of all the planets in our solar system. Yeah, Jupiter and Saturn alone comprise something in the order of 90% of the mass of our solar system outside of the Sun. Um, yeah, excluding the Sun, Jupiter and Saturn alone have most of the mass in our solar system. But yeah, excluding um, Saturn, Jupiter alone has, yeah, like I said, 2.5 times the mass of the other planets. Now, um, now this object that I have, that I mentioned, I'm not repeating that name. Okay, maybe I should. Just a moment. Ogle, OGLE, 2016, BLG 1190 is yeah, basically right on the boundary between a planet and a type of failed star called a brown dwarf. Now, the higher the mass of a brown dwarf, the more star-like it becomes. Um, Now, the minimum mass for a brown dwarf to start fusing hydrogen into helium like a proper star, it should have a mass of at least 80 Jupiters, as in 10 times 8. About 80 Jupiter masses. Um, and then at that mass, it starts to properly fuse hydrogen into helium, and then it becomes a red dwarf. Now, red dwarfs are extremely long lasting, trillions of years, but I will talk more about red dwarfs in this next sub series that I'm going to start after the house setting. But yeah, it's going to be quite interesting, and this planet or brown dwarf planet slash brown dwarf orbits its star um, basically at a distance of 2 astronomical units or AUs. Um, 1 astronomical unit is the distance between the sun and the earth, or about 150 million kilometers. So the distance between the star and this planet slash brown dwarf is just 300 million kilometers. Um, yeah, it's in this in the middle of this of a brown dwarf desert. Okay, that's something I haven't heard of yet. Um, okay, just a moment. Okay, from what I'm reading here, um, from the dog from the Guardian.com is I'm gonna look more into this because this is something I haven't heard of yet. Now it says here, now I'm quoting, ever since the first planets around other stars were found in 1995, astronomers have been surprised by the lack of brown dwarfs in orbits around other stars closer than 5 times the Earth's distance from the Sun. The seemingly forbidden zone is what they have termed the brown dwarf desert. Now there is a quote from the Guardian.com. Um, now it goes on here. Um, it's still from the Guardian.com. So it's not my quotes. It's from the Guardian.com. One possible reason for this for it I- sorry one possible reason for it is based on how brown dwarfs might form. Planets grow from the accumulation of smaller asteroid-sized chunks of rock and metal. Stars, and possibly also brown dwarfs, form from the collapse of a gas cloud. It is unlikely that there would be enough gas close to a star to collapse and form a brown dwarf, because the gas would be driven to more distant, colder regions of the by the heat of by the heat from the star. So basically, from what I get from that quote, um, remember, I only heard about this now, is and it actually makes sense actually as well. Um, when a solar system forms like ours, um, inside a certain area, now around um, now around most stars, there's okay, let's take the sun for example. Around the sun, there's this zone or area called the frost line, which would be located round about where the asteroid belt is. Inside the frost line, the temperatures during the solar system formation will have been above the melting point of rocky and metallic um, material, or but basically inside the frost line, temperatures were at a point where rocky and metallic material could condense into solid material, while outside, no, sorry, forget that. I'll get to that part just now. Also, um, inside the frost line, the temperature would have been too high for ices or ice to form, um, the temperature would have been too high for water ice to form, but low enough for rocky and metallic material to condense, while beyond the frost line, ice could form, and this is where gas planets, gas and ice giants could form, like Jupiter, Saturn, Uranus, and Neptune. Basically, they formed out of the solid ice beyond the frost line. Um, Now, basically, just like a star, they also condensed out of, or they formed out of almost like a star where denser parts of this gas and dust disk were denser, which then collapsed into um, the cores of these planets. And once these cores reached a certain size and mass, they drew more and more material, and as they did so, their size, mass increased. So basically, it was a positive feedback loop. The more material these cores drew in, the more their mass in the more their mass and size increased, and the more material grew it sucked in, and this included some rocky and metallic objects or material, as well as ice, water ice, ammonia, methane, as well as any remaining hydrogen and helium that haven't been that didn't get blown away yet. Um, you see, during the solar system formation, there were also other stars nearby, and that were also busy being formed, created, and some of these stars formed earlier than our sun. See, our sun was still at the protostar stage. And then when these stars formed first, some of them, including the sun, but I will talk more about that in a later video. Um, the solar wind from these stars, especially the sun at this point, started to slowly push away the hydrogen and helium, and the planets, especially the outer planets, um, grew very quickly during this stage, um, quite fast actually, um, less than 100,000 years. So these central rocky, metallic, and icy cores grew so fast that at some point they started to really suck in a lot of hydrogen and helium before it was blown away. And this is also where brown dwarfs form from the in the same way and in the same area, um, and from the same material, mostly hydrogen and helium, with some heavier elements within the gas and dust um, disk, or protoplanetary disks, or what are they called again? Proplets? Yeah, that's a weird name. Proplets, but in the cold cold outer parts of this protoplanetary disk, this is where brown dwarfs formed, um, just outside of the frost line, where there were still huge amounts of hydrogen and helium. So for this um, object to be inside the frost line, where it should not have been able to have formed, is quite unusual. But it's possible that it may have migrated inwards because of um, drag from the protoplanetary disk. Um, yeah, this disk may have caused this brown dwarf to slow down and slowly but surely start spiraling inward until it reached a stable orbit. Um, Now the same thing would have happened in our solar system, where the disk, material disk, may have caused Jupiter to migrate inward slightly, which then caused this planet migration in our solar system. But this inward movement of Jupiter would have been stopped by Saturn, which is the second most massive planet in our solar system, with a mass of 95 Earths. It had just enough mass to stop Jupiter in its tracks and cause it to go into the orbit that it has now. So, yeah, thank goodness that Saturn formed at the point that it did. Otherwise, the solar system would be completely different, and I would not be here to talk to you guys, because Jupiter may have, well, actually, it would have caused major havoc on the inner solar system had it migrated any further. Um, yeah, it may have kicked some of the inner planets outwards: Mars, Earth, Venus, maybe Mercury as well, depending on how much further it will have migrated inwards towards the sun. Um, yeah, we actually see that a lot actually as well with other solar systems, where we find massive Jupiter-sized planets orbiting very close to their planet stars, and they are called hot Jupiters, and they orbit their stars just at a distance of just a few million kilometers. And now the largest planet of the now the largest of these planets is WASP B. Yeah. Um, Now it has a diameter of twice that of Jupiter's. Um, Now before you go looking it up, or maybe you should, yeah, I will also look it up, and I will let you guys know in my next video. But WASP B, it's also one of these hot Jupiters, and it has a very low density, even lower than basically um, something similar to that of Saturn. Now, that's about it for now, and I will see you guys in the next video. Um, Now, depending on how it all goes, maybe maybe my next video will be released on well, I'm hoping either Saturday or at the latest Sunday. Um, yeah, either Saturday or Sunday will be probably my last video that I'll be able to upload. Um, yeah, I'll try to record it on Friday, um, and then yeah, I'll record it on Friday, which would be tomorrow or today, recording it since I'm recording this video on Thursday. Yeah, the Thursday, the 16th. So, Friday, 17th, I will hopefully record my next video. Then on the 18th, Saturday, or 19th, Sunday, I'll upload my next video. Hopefully it all goes correctly. I hope so. But if not, I will see you guys after the 27th. Okay, 20. I will see you guys again after the 27th. Again. Um, I'll miss you guys until then. So I hope you guys subscribe, leave your comments if you do, if you like. Yeah, I really I really want this channel to go off, and if you like this video, if you like the videos that I'm making, please leave a like and please leave a comment on what I could do. But if not, yeah, just tell me what I could do to improve myself. And okay, until someone tells me what I could talk about in my next video, or what you want me to talk about, for now, I will continue with the series that I'm doing with the planets, and after the 27th, the stars as well. Um, Maybe the occasional movie review once in a while as well. If you guys have a request. And yeah, see you guys in the next one. Cheerios, guys. And have a good one!